Alright, so now we're going to first work with these three functions to find the maximums and minimums over the entire domain. So first we need to take the derivative and see if we have critical points. And so the algorithm will be take the derivative, so find the derivative. Next is when the derivative is equal to 0, so derivative is 0 or undefined, so is finding the critical point. And the third step is to draw our sign table and see in which parts over which interval is the function decreasing or increasing in relation to the critical points, and from that we will at the end find the extreme maximum or minimums over the entire domain. So first here h prime will be 12 cube x plus 12 square x minus 24x. We can put this as 12x times square x plus x minus 2. And this is the same as 12x times x plus 2 times x minus 2. So our critical points is when does h prime is undefined, there is no point. Where does the function, the derivative of the function h prime is equal to 0. It will be either when x is equal to 0 or negative 2 or positive 1. So this will be the line. Here we go negative 2, 0, 1. So when x has values that are greater than 1, all the three terms will be positive. So this will be a positive slope, and so the function will be increasing. So this here the slope is positive, and is increasing. If I do first the extremes. Now if all the values are negative, so we are in values that are negative lesser than negative 2, so the 3 will be negative, and so negative times negative, positive times negative, negative. So the function is decreasing because the slope is negative. Now when we are between 0 and 1, the only term that is going to be negative is this. So positive times negative is negative, so the slope will be decreasing. And the function will be decreasing because the slope is negative. Between minus 2 and 0, and the function will be, the term will be negative, positive, negative. So negative times negative, positive times positive, positive. So the function will be increasing because the slope is positive, has positive sign. So this is translated to, for values that are less than x equals minus 2, the function is decreasing. Next it is increasing between x equals minus 2 and x equals 0, then decreasing again from x equals 0 to x equals 1, and next continue to increasing. So this would look something like, if this is negative 2, this is 0 and 1. So for these values, the function is decreasing. Could be positive or negative, but is this decreasing? Let me put something like, so it's decreasing, so it has negative slope. So I can put something like this. It has something like this. Then at x equals minus 2, it has a, actually if you see it, here the extreme points, if you see it, we have critical points that are minus 2, 0, and 1. Now in order to be minimum or maximum, we need that from a minimum we switch from negative to positive. So here we have 2 that could be negative or could be extreme values. Now for the positive, the only candidate is this, because the function here is going all the way up. So we have a relative maximum, yes. Relative maximum, yes. Now the absolute maximum, we do not have it. Look. So the function is decreasing. So first we have a negative slope that is something like this. Let's say like this. Next, here the slope is 0. So it's something like this. Then the function is increasing. Then the slope is 0 at x equals 0. So something like this. The function is decreasing. At x equals 1 has another relative minimum, and the next it is increasing again. So this is more or less the graph. The important issue is that this is the graph of h of x, and this is x. So here the function is decreasing, neither increasing, decreasing, slope 0 and increasing. So we have a relative maximum at here. We don't have a absolute maximum because, you know, when we walk from the limit as x approaches negative infinity to the limit as x approaches positive infinity, here the limit is infinity, and here the limit is also infinity because we are coming from we don't know where, and we are decreasing. The function is decreasing until x equals -2, in which begins now to increase. So we don't know how high is the function. It goes to infinity from as x approaches negative infinity and as x approaches positive infinity. So there is no, h has no absolute maximum, but we have absolute minimums that are in negative. Well, we have relative minimums that are in x equals -2 and x equals 1. If we want to know what is the absolute minimum, we need to evaluate the function at x equals -2 and x equals 1. So I think that would be a little bit further. So it would be 16 times 3. 16 times 3 is 48, plus 4 times 8, 32, minus 4 times 12, 48, plus, oh, sorry, here is a negative 32. So this is negative 27. And now when x is equals to 1, would be 3 plus 4 minus 12 plus 5. It would be 7 plus 7, it would be 0. So the absolute minimum is negative 27. So h of x has no absolute maximum, has the absolute minimum is that x equals -2, and is when y or h of x is 27, is negative 27, and the function has a relative maximum that is here at x equals 0, and no and another relative minimum that is when x is equal to 1. So this was the first example. Now in the other example, we now can do it quickly. So we have g of x equals to -3 x to the 4th power plus 8x cubed plus 18x squared. If you think you can do it, stop the video now and next continue to see if we have the same result. Alright, so g prime of x would be -12 square x plus 24 square x to cube x plus 36x. G prime of x is equal to let's say -12x times square x plus 2x plus 3. This is -12x times x plus 3 times x minus 1. So what are the critical points? The function is never going to be undefined. The derivative is never going to be undefined. Can be equal to 0 when x is equal to 0, to 1, or negative 3. So negative 3, 0, 1. When all the terms are positive, when all the x's are positive, well, this term is positive, this term is positive, and this term until here is positive, but we have a negative sign here. So slope is negative, the function is decreasing. When everything is negative, 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 times this negative, everything becomes positive. Now, between 0 and 1, the only term that is negative is this, and this negative times this negative is positive. Between negative 3 and 0, this is negative, this is negative, this is positive, so negative times negative positive, both times this negative sign, this is negative. So now, as we go from negative infinity to positive infinity, the function is increasing, so we are coming from here, this is negative 3, 0, and 1. So the function is increasing, so we'll come from here, it is increasing until x equals negative 3, and the function begins to decrease. The function could be something like this, for example, or could be something like this. We really don't know. Well, I'm not paying especially care in this moment at in which part we have the extreme point. Well, anyway, it looks something like this. Then is decreasing until x equals 0. We have this slope of 0, and next we are increasing again, and then decreasing again. So the function has no absolute minimum because we are decreasing here and we are decreasing here. So we have no absolute minimum. There is no absolute minimum. No absolute minimum. We have a relative minimum, yes, at here, that is this point. At x equals 0, we have a relative minimum. We have these two are maximums. Now, which would be the absolute maximum? Well, we need to evaluate the function at x equals negative 3 and at x equals 1. So, well, we could do that, but we don't do it here. So, yes, this function has a relative minimum, a global or absolute maximum, another relative maximum, and no absolute minimum. Alright, now, in the next video, we're going to talk about harder problems. So, now just the last one for this. This is f of x is equals to negative 3x to the fourth power minus 8x cubed plus 6 square x. So f prime would be negative 12x cubed minus 24x squared minus 12x. This is minus 36, minus 12x times square x plus 2 plus 1. So this is, 2x. So this is minus 12x times x plus 1 squared. So the only critical points are x equals negative 1 and 0. So this is negative 1, this is 0. When everything is positive beyond 0, we have this sign that makes it negative. Everything is less than negative 1, so everything is negative. But here, oh look, here the only term that, or the terms that determine if the slope is negative or positive is only this term. Because here it doesn't matter what value of here we have, we are squaring it, so it doesn't matter. So if we have a positive, let's say above 0, this is a negative. If we have a negative value, this will be positive. Between negative 1 and 0 is a negative value, times this negative is positive. So we don't care about this. So this function is here is negative 1, here is 0. So the function is increasing. So increasing has this slope. It is increasing. And let's say increasing until x equals -1. It has a slope of 0, but continue increasing. So continue to do something like this. And the next at x equals 0, slope of 0, and now begins to decrease. So look, this is a not. This is a not extreme point. It's not a relative maximum nor minimum, because we are passing from positive to positive. If you see all the time, the slope is here is positive 0, and the next continue to be positive. So there is no change. So the function, the limit as x approaches negative infinity is negative infinity, and here the limit as x approaches positive infinity is also negative infinity. So there is no absolute minimum. We have no relative minimum. Here we are not passing from negative to positive, nowhere. We have one absolute and relative, that is here. Just at x equals 0, we have this extreme point, that is the absolute. This point was only critical point, was only a candidate for a maximum or minimum, but there is no extreme value here because there is no change in this slope. So in the next video, we're going to